Here we're on optimization part 9. This one's called making silos. We have a grain silo, consists of a cylindrical concrete tower surmounted by a metal hemispherical dome. So I've got the concrete cylinder, and then up here is the hemispherical metal dome. If the volume of the silo is 750 cubic meters, what are the dimensions of the silo, radius and height of the cylinder that minimize the cost? I think I missed, here we are. Second sentence. The metal in the dome cost 1.5 times as much as the concrete per area of surface, per unit of surface area. If the volume of the silo is 750 cubic meters, what are the dimensions of the silo that minimize the cost of materials? Assume the silo has no floor, so just flat ground down in here. So I don't have to include that in my surface area calculations. And what else here? And no flat ceiling under the dome. Okay, so this here is just empty, cavernous. All right, so they tell us that the dome cost 1.5 times as much as the concrete, but they don't tell us what it is, so we'll just call it something. We'll say that this price is P dollars per unit. That's for the cylinder part. And then up here is 1.5 P dollars per unit. Okay, so what I need then is to get the total surface area here to get the total cost. So let's take a look at the cost of this part. Well, I need the area of the cylinder, the surface area. And if you don't know that, we have got to give it some labels right now. I am going to call from the center out. I'll let that go by lowercase r for the radius. And note that that's the same as up here, because this thing up here has the same radius. Has the same radius as the circle, in fact. The sphere, I mean. And then let's call this h, giving these the names, and that only goes up to the end of the cylinder. All right, so what is the area of this? Well, if you don't know, the area of the cylinder is 2 pi r times h. So the cost, that'll be 2 pi r h, that's the surface area, times p, because it costs P dollars per unit. So that's the cost of the cylinder part. And if you want a way to think of a way of getting that formula, what I tend to think of myself as doing is if I were to cut a slice down, straight down it, and lay it out flat, like a sheet of paper, nobody has a problem with that being h. But down here, when you roll this out, this has the circumference of this circle as the length of the base. And that's why it's 2 pi r. All right, I'm going to take that out. I just cluttering things right now. Now the cost of the dome. The cost of the dome is 1.5 P times the area. Now the area of a sphere is 4 pi r squared. That's the surface area of this sphere, except it's only a half a sphere. So I need 1/2 of that. And then times 1.5 P. So the total cost That is C equals 2 pi r h p and plus, so there's the cylinder. Now I'm adding in the dome. This, when I change 1/2 times 4 will be 2. Now if you take 2 times 1.5, that'll be 3. So I'll have 3 pi r squared p. Now p is a number that's assigned here. It's not, they're not trying to find the price. They're trying to find dimensions, the radius and height of the cylinder tower. They're looking for R and H that minimize the cost of the materials. They didn't say anything about the actual cost. So what happens actually is this P will drop off somewhere in this problem. So really the only two, P is fixed, though. You should keep that in mind. And in fact, I'm going to rewrite it as this so that you know what's fixed and what isn't. 2 pi P RH plus 3 pi P times R squared. Though I've got all the constant stuff in the front of these. Now then, the only variable I have is R and H, so I need to connect them somehow. And what connection do I have for them? Well, I know the volume of the silo is 750 cubic meters. Just to remind you, this is the objective function. Now, a constraint that we're given is that the total volume equals 750 cubic meters. So what is the total volume? Well, the total volume is the volume of the cylinder plus the volume of the dome. So let's get the volume of the cylinder. One of the volume formulas that you should know, it's not actually a formula, it's if you have some sort of what they call a prism device, a device that stays the same from bottom to top like this, then to get the volume, it's the area of the base times the height. The area of the base is pi r squared and then times height. And then we want the volume of the dome. Oops. And that's the volume of a half sphere. So normally the volume of a sphere is 4/3 pi r cubed. In this case it'll be 2/3 pi r cubed. So the total volume well, on the one hand we're told it's 750 cubic meters. On the other hand, it's the volume of the cylinder plus the volume of the dome. So we have pi r squared h plus 2/3 pi r cubed. Now, if you look at this, I need to either get r in terms of h or h in terms of r. If I try to solve this for r, look at this, I have an r squared and an r cubed. It's going to be virtually impossible to isolate r and solve it for h. Instead, in the formula that we had, for the total cost, there it is, you only see h appear one time. So if I can replace just that thing, then I'll have all r's, and of course the lowercase p, which is a constant. So I'm going to solve this for h. So with that in mind, the first thing I'm going to do is multiply everything by 3. So I get 2250 equals 3 pi r squared h plus 2 pi r cubed. Now I'll go ahead and subtract 2 pi r cubed. And then to get h by itself, I'll divide both sides by 3 pi r squared. Okay, now the thing I'm trying to minimize is the objective function here. Let me bring it in, copy it. So now I'll substitute for h wherever I see it. Remember, I was doing 2 pi p r, and then h is all of this stuff. 2250 minus 2 pi r cubed all over 3 pi r squared. And then plus this part. Plus 3 pi p r squared. So now if you'll notice, the only variable I have is r. Now let me do some simplifying. What can I simplify? I can take out a pi in the first expression. I can also take out an r in the numerator and denominator. I think what I'll do with this portion of it, I'm going to keep the 2p, obviously I have to keep that 2p, but what I'm going to do here is break this up into 2250 divided by 3r minus 2 pi r cubed over 3r plus 3 pi p r squared. Okay, now I know that 3 goes into 2250 750 times. So I have 2p times 750. I'm going to put r to the negative 1. It's easier to differentiate with that way. And here I can take out an r and have minus 2 pi over 3 r squared. And then I have plus 3 pi p r squared. Now if I multiply this all out, which I think I will so that I can combine terms and whatnot, I'll get 1500 p r to the negative 1 minus 4 pi over 3 p r squared plus 3 pi p r squared. Now in particular, I can combine these. If I think of 3 pi as 9 pi over 3, I'll get 1500 p r to the negative 1 plus 5 pi over 3 p r squared. So this is what be my objective function in terms of r. Now because of this r to the negative 1, this function is not defined when r equals 0. So that means I do not have a closed interval to work with. So I'm not necessarily guaranteed an absolute max or an absolute min. When we have something like this, there's something else that you have to do to check to see what it is. You can graph it, of course, but I'm going to try to do it without graphing and explain to you how you can do it just using calculus. So the domain, technically speaking, is 0 to infinity. Let's go ahead and take the derivative and set it equal to 0. C prime of r equals negative 1500 p r to the negative 2. Bring this 2 down and you get plus 10 pi over 3 p times r. Now of course you're going to set this equal to 0, so we have 0 equals negative 1500 p. I'm going to put it over r squared. It just is convenient for me right now. Plus 10 pi over 3 p r. I thought this might happen. I'm going to divide both sides by p. So I'll be left with 0 equals negative 1500 over r squared plus 10 pi over 3r. So you can see the p dropped out completely. It's not even necessary. I think what I'll do is take this 1500 over r squared to the other side, and I'll get an expression like, or get an equation. 1500 over r squared equals 10 pi r over 3. The reason why I wrote it that way is because I'm going to cross multiply next. So I get 4500 equals 10 pi r to the third. I'll divide by 10 pi, and I'll get 450 over pi equals r cubed. And then I'll take the cubed root of everything. R equals the cubed root of 450 over pi. Now, how is it if I got no endpoints to test this against? How do I know that this is going to be the lowest thing? This will yield the lowest cost. Well, what you want to do is go back to where we took the derivative, which was right here. Keep in mind that r is positive, because what I'm going to do next is take the second derivative, c double prime of r equals, this time when you bring the negative 2 down, you're going to get positive 3000 p r to the negative 3. And over here, the r will simply disappear, and you get 10 pi over 3p. Now, the underlying assumption here also is that the price per unit is a positive number. So this piece is positive. If r is positive, r to the negative 3 is positive. C double prime of r is greater than 0 for every r. So it's concave up. What that means is, if you think about this, for going from 0 to infinity, probably does something like this, if I had to guess. This way it's not concave up, it has the asymptote at r equals 0. Down here at the very bottom here must be the r that we found. That must be the cubed root of 450 over pi. So since it's concave up at our critical value, we know that we have minimized the cost. So I have r, and now I need h. Let me see if I can find an expression up there somewhere for h. So let me go ahead and simplify what I can. I got 250 minus 2 pi. Then I have the cubed root of 450 over pi, but if I take it to the third power, then I'm going to have 450 over pi. And in the denominator, I'm going to have 3 pi r squared. So I'm going to have this to the second power. So I'm going to have 450 over pi squared, but the cubed root of that. And I'll tell you what, I don't like that, so let me get rid of it. I'm instead going to write it as 450 over pi to the 2/3 power. That's much better. Now let's see what cancels. Here we can cancel these pi's. Down here, this is a little complicated. Let's address this after I get the numerator finished. Okay, so I'm going to be left with negative 900, 2250 minus 900, so 2250 minus 900 divided by 3 pi cubed. I don't know how that cube got in there. It's not there. Come out of there. Come out. 3 pi times 450 over pi to the 2/3. 2250 minus 900 is 1350. I can cancel the 3 because that goes into 1350 450 times. So I'll have 450 over pi times 450 over pi to the 2/3. Well, I think what I'll do is write this finally as 450 over pi times 450 over pi to the negative 2/3. So here I have something to the 1, and here I have something to the negative 2/3. So my answer then is 450 over pi to the 1/3, which happens to be exactly what we got for h. H is the same thing. To the 1/3 is the cubed root. So we can say that r equals h equals the cubed root of 450 over pi meters. And there you go.